Okay, I just wanted to make a little screencast here as I'm away for the next few days at a conference. So just some things to, I don't know, maybe help you along with a few things. Really what I want you to work on is exercises 4A through to 4D. Now in that section we're sort of heading towards the derivative and calculus. And we're dealing with this concept of limits, aren't we? And so we've been looking at that, and so what I'd like you to do is spend the next few days just looking over a few of those ideas, and that really leads us into the underpinnings, the sort of the birth of calculus, I suppose. So what does this limit stuff mean? And we've looked at some calculations, haven't we? So I just want to have a look at a few more and explore a few concepts. So I want to have a look here at, say, the limit, and I'm just sort of pulling a few things out of the textbook. Say, what happens when we look at situations where, let's say, limit as x approaches minus 1 of x squared minus 1 over x plus 1. Now clearly at minus 1, that substituting straight in gives us 0 here. So we've got a discontinuity at minus 1, and we know that there will be if we're going to draw this thing, then there'd be an asymptote here with at minus 1 when there'd be a break, because minus 1 is not defined. How do we find it though? How do we find the limit? What's the value as it gets closer? Well, there's a few things we can do here. I mean, what we can do is we could try factorizing this. So we get x plus 1, x minus 1 on top, and underneath we get x plus 1, and then they cancel. We're left with the limit as x approaches minus 1 of just x minus 1, and when we sub the minus 1 in now, we get minus 2. So in fact, this thing's heading towards minus 2 as my x value goes towards minus 1. Now that would indicate, would it not, that we have a so what this thing actually looks like is just this function here, y equals x minus 1. If you think about this simplifies to x minus 1. So of course that's the graph of it. So it's a straight line going through here. But so x minus 1, if we just drew that, would go through, wouldn't it? We've just got to break it there, and then it just runs through. It's a straight line going through minus 1 there, 1 there. So this is y equals x squared minus 1 on x plus 1. It's a straight line, but it's discontinuous at the point x equals minus 1, and at that point, at x equals minus 1 here, the y value is minus 2, and that's our limiting value. As x approaches minus 1 from this side, we're approaching a function value of minus 2 from both sides, discontinuous at that point. If we just want to have a look at how we establish horizontal asymptotes, because we've seen here how vertical asymptotes come about. It's where our denominator equals 0, so it's the value of x for which the function has is not defined. It's not something we can calculate. Horizontal asymptotes, how do we calculate those? So for example, we might want to sketch the graph of y equals x plus 2 over 2x plus 3. Okay, so the technique here is really, we want to know what's happening as values of x get larger and larger, just to see where it's heading, what value of y you're getting closer to, but never quite reaching. And if we had a look at this, and if you put in, I don't know, just crudely put in a value of x equals 1,000, you'd have 1,002 over 2003. I'm having struggle writing. If you put in 10,000, you'd have 10,002 over 20,003. Now, what are these pretty close to? And as this gets bigger and bigger, and this gets larger and larger, it's getting closer. I would have thought it looks like 10,000 over 20,000. It's getting close to a half. Well, how do we do that algebraically? Well, this is how. What we do is we algebraically work it out by dividing. What we do is we divide through by the highest x power in the denominator. Right, that's our method. So let's do that. Go back in. All right, so y equals, we're going to divide by the highest x power in the denominator. Now the highest x power in the denominator is just this x here, so we're going to divide through by x. So we get x on x. So right, isn't it? We can do this. This is algebraically legitimate. 2x over x plus 3 over x. Now when that simplifies, you end up with 1 plus 2 over x over 2 plus 3 over x. And you can see what's resulted here, that 1/2. And in fact, what we're doing is we're dividing through by the highest power of x in the denominator, and then we're taking the limit as x approaches infinity of that expression. So the limit as x approaches infinity of this will equal, well, these go to 0, don't they? Any fraction with x in the denominator, as x gets larger and larger and larger, they go to 0. So we're just left with this 1 over 2. And that's our horizontal asymptote. So now we can get to work on the graph, and we can say, right, well, 1/2 is my horizontal asymptote, so I'll whack that through there. Do I have a vertical asymptote? Well, yes, I do. It's when 2x plus 3 equals 0, so when x equals minus 3 over 2. That's going to be over here somewhere. X equals minus 3 over 2. Remember, this is equal to 1/2, and we're getting close to what this thing looks like. And then we just see, right, when x is 0, I've got 2/3. So when x is 0, so that means 2/3, I've got a y-intercept, 2/3, so I've got to make sure it goes through there. And I imagine that what's happening is it's coming down through 2/3 there, and it's approaching that horizontal asymptote. And over this side, when is y equal to 0? Well, it'll be y will be equal to 0 when x is equal to minus 2. And this is minus 1.5, so it's going to be down through here like this. And that'll be at minus 2 is where it'll cross the axis there. And that's roughly what our graph's going to look like. Okay, what's going to happen with, say, y equals x plus 2 over x squared plus 1. So looking for a horizontal asymptote. So horizontal asymptote will find by taking the limit as x approaches infinity of, right, we're going to take this now and divide by the highest power of x in the denominator, which in this case is x squared. So it's x over x squared plus 2 over x squared. And you see what's happening here, x squared over x squared plus 1 over x squared. So we end up with the value of this limiting as numerator 1 over x plus 2 over x squared, 1 plus 1 over x squared. So these all go to 0, so we're left with 0. So the limit, the horizontal asymptote is 0. So we can work that through. So the horizontal asymptote is the x-axis. And what happens? Where is this? I don't think there's any vertical. Is there a vertical asymptote? Is there a value of x that gives us 0 under here? No, there's not. So what about when x is 0? We get 2 over 1. So we know it's going through. It's going through here at 2. When is y equal to 0? Well, that's when x equals minus 2. So down here at x equals minus 2, we've got y equal to 0. So I suspect we've got something like this happening, where it comes through, goes through there, but back and around, and heads back up towards the x-axis in there, somewhere like that. That would probably be the sketch. No other way really of forming that. What I would like you to do, I'm going to sort of end it there, but I'd like you to have a look at example 9 as well. It's just another type of question using sigma notation. On page 180, and that leads into exercise 4D. So when you get up to that stage, but if we can sort of work through 4A to 4D, and then we'll get stuck into the calculus side of things, the differentiation and that sort of thing, next week. So I'll see you then.